Okay, so this is the source code that Igor has sent me. Hi Igor, thank you very much for sending me your source code. You've done a great job. Let's go through what you have done so far, and then I'll point out a few things that you can improve here. So I notice you declare this interface called iWorkflow with a method called execute. And then you have different classes that implement this interface, like video uploader, call web service, and so on. And you also have a workflow engine, which has a list of iWorkflow. It exposes two methods for adding a workflow object using that interface and removing a workflow object. And finally, it has a run method that iterates over the list of workflows and executes them. And in your main method, you simply instantiate a workflow engine, add different workflow objects, and run it. So what I like about your implementation is the loose coupling. So I see your workflow engine is not tightly coupled to implementation of your actual workflow objects like change status or send email. It purely talks to an interface, iWorkflow. So great loose coupling. Now let's see what we can improve here. The first thing is this change status or send email is not really a workflow, because a workflow is a collection of tasks or steps or activities, whereas each of these classes represent only one step. So a better name for this interface would be iTask or iActivity. If you look at the description of the exercise, let me open it up here. So take a look here. Here it says a workflow is a series of steps or activities. The workflow engine class should have one method called run, which you have done perfectly, that takes a workflow, which means a collection of tasks. So the first thing I would suggest to change here is renaming that iWorkflow to iTask, and simply with ReSharper, iTask. Okay, now let's take a look at our iTask. So task has a method called execute. So each task can be executed. Perfect. Now we need a separate concept for the workflow, because a workflow is a collection of tasks. So what I would do here is I would declare an interface called public interface iWorkflow. Now we should be able to add or remove a task from workflow. So these methods that you have in the workflow engine really belong to the workflow itself. The reason I prefer to take them out of the workflow engine is because in the real world, a workflow engine is far more complex than what we have for this exercise. For example, in your workflow, you might do exception handling, you might do logging, you might persist the state of your workflow. Let's say your workflow has 10 steps and it needs to go in a hibernate mode after the third step, because it's going to be a delay until we hear back from the fourth step. So you need to be able to persist the state of the workflow in some kind of persistent store like a database or file or whatever, and then rehydrate the workflow from that later. So I would prefer to take these methods out and make this engine purely responsible for executing a workflow. So what I'm going to do is in workflow, I'm going to introduce two methods, add a task and remove a task. Why is it complaining? Okay, the problem here it says inconsistent accessibility. Parameter type iTask is less accessible than method remove. What this means is because we declared this task without an access modifier, in this case public, by default is assumed to be private. So we cannot declare a public interface that uses a private interface. We need to make this public. Right? Now, let me implement a basic workflow class. That of course should implement iWorkflow. With Alt and Enter, we implement the members. Now what you had here in your workflow engine is pretty much what we need to push into the workflow class. The concept of a list of tasks and adding or removing tasks to it. So I'm going to cut this. And well, we already have that here. Let me just temporarily paste it. we need to change the name of the constructor to match the class name. So copy, paste. So that's my list of tasks. Also, it's better to use a different name than T. The first thing that confused me when I saw T here, I thought you're working with a generic type. And T is a common convention to represent generics in C#. If you're not familiar with generics, take a look at my C# Advanced course. That's the first lecture in that course. Now I'm going to rename these to underline tasks. Now we have a green underline here. ReSharper is suggesting to make this field read-only. And I think I have explained the reason for that in my course. Let's make it read-only first. The reason for that is we initialize it here in the constructor, and we don't want to accidentally reinitialize it because that list can already have some objects in it. We don't want to accidentally lose those objects. All right, so what you had in add workflow object, I'm just going to move to this add task. And instead of I object, we're going to call it task. So I'm thinking you probably come from C++ background because I see you have used the Hungarian notation here, but that's not a common convention in C#. So we don't prefix the name of our objects with their data type. Now let's remove this method. I'm going to remove your implementation from this method, remove workflow, to remove task here. And of course, we want to change iObject to task. And finally, I'm going to remove this method. All right, now let's revisit this. So we have a workflow class, which implements iWorkflow. It has a collection of tasks, and you can add a task to it or remove a task. Again, if you look at the exercise description, that's exactly what we wanted. A workflow is a series of steps or activities. One more thing we want to change here is, let's go to your workflow engine. All right, this class is not going to compile now. First, let me make it public. Run method should get a workflow and run it. So iWorkflow, that's it. Now here we need to access the list of tasks that workflow represent. So we need to go to workflow class. And here we need a separate method for returning the list of tasks. I'm going to use the IEnumerable interface, and I'll explain that shortly. Get tasks. Simply return tasks. Why did I not use the list class? The list class, as you see, has methods for adding or removing a task. I don't want the caller or the client of this class to work directly with the list that this class is internally representing to hold its tasks. This is the implementation detail of my workflow. That's the reason we added these public methods here for the client of this class to use to add a task to this list. If we expose the list here instead of IEnumerable, the client of this class can go directly in this private list here. In this particular example, it makes absolutely no difference if we call the add method, like here, or get a reference to underlying tasks and call the add method on that. But you could have scenarios, for example, you could do some kind of check-in in your add method. This way, you definitely do not want to expose your private list, which is the implementation detail, to the clients of this class. You want to make sure that they go through this add or remove method because some magic is going to happen. And this is all about encapsulation that I talked about in the course. All right, now that we have a method to get a list of tasks, and by the way, the return type is IEnumerable. So if you take a look at IEnumerable, it's simply an interface that is defined in system.collections.generics. iTask. Let's just declare A here. Look, it does not have a method like add or remove. It's purely an interface that allows us to enumerate a list. That's it. So this way you return a read-only version of your internal list. All right. Now let's get back to our workflow engine. So here we tell the workflow.getTasks. Okay, this method is not declared in the iWorkflow interface, and that's why it does not appear here. So, see, we added that in our workflow. It's here, not in iWorkflow. So what I'm going to do, copy this bit, paste it here. That's it. Now let's go back to Workflow Engine. That's our run method now. Takes a workflow and iterates over its tasks and execute each. Very, very basic. In a real world scenario, perhaps you might want to surround this with a try catch block. So something like try, run this, and if there is an exception, you would probably want to do some kind of logging and maybe terminate the workflow, terminate and persist the state of the workflow, something like that. And then later, you may get that workflow and resume it. It's beyond the scope of this exercise, so don't worry about it. It's just to give you some idea. Now, we still have some minor errors on this page because it's not going to get compiled, as you see indicated here. So let's jump up here. Of course, we change our workflow engine, the name of methods. So here, instead of calling the add workflow object and workflow engine, we need to call that on the workflow, not the engine. So I'm going to change this to workflow. And of course, here as well. And I'm going to change all of these methods in one go to add. Now finally, we need to create a workflow engine. So I'll call it engine, new workflow engine. And then I call the run method and pass my workflow. And it's better to change this to var, make the code a little bit cleaner. That's pretty much it. Let's run the application. So each task was executed, uploading a video, calling web service, sending an email, and status changed. That's pretty much it. Again, thank you very much for sending your source code and sharing it with others. You've done a great job, and I'm happy to see that you've really understood the concept of loose coupling. We just had to move those add and remove methods from Workflow Engine to the Workflow class. I hope you enjoyed this video, and thank you for watching.